This is just part one of the review videos for the first exam for 1010. So we'll just go through a couple problems here. Up to 25. The review problems up to 25. So first of all, it says, are these solutions? Tell which are solutions. So what I would do, first of all, a couple ways to do it. You could just solve directly and circle the answer, or plug in 5 and 6 and see what's a true statement. To me, it's just easier to just go ahead and solve and then compare it. So I'm going to subtract x, add 4. So then over here, I have a 2x. That's gone, equals 6 plus 4 is 10. So x equals 5. So then I would know 5 is a solution, 6 must not be a solution. All right, same thing here. I think it's just easier to go ahead and solve. So we have 4y. Make sure you distribute your negative. Minus 1 plus y plus 5 equals, make sure you distribute negative 2 in here. So we have a minus 6, and then it looks like minus 6y, then plus 10 minus 2y. So then on this side, combine like terms. So I have 4y plus 1y is 5y's, negative 1 plus 5 is 4, is equal to, on this side, combining like terms. So I have negative 6y minus 2y, negative 8y's. And then I have a negative 6 plus 10, which is plus 4. So now we can go ahead and solve. I'm going to go ahead and add 8y to both sides. Subtract 4. 13y equals 0. Divide by 13. So y equals 0. 0 divided by 13. Notice 0 is in the numerator, not denominator. It's a problem if the 0 is in the denominator, but since it's in the top, we're all good. So the solution is y equals 0, not negative 2. Number 7, solve for x. Pretty straightforward. Combine your like terms. 7x minus 1 equals 20. Add your 1. 7x equals 21. X equals 3. That is considered a conditional. Make sure you know these, conditional solution. And just a reminder, if we were to solve and get answers all real numbers, that's considered an identity. If we were to solve and the variable canceled out and we got a not true statement, then there would be no solution. And that's considered a contradiction. So just a reminder on the 3 types of solutions you will see when solving. Number 9, we'll distribute negative 2x plus 8 equals 8 minus 2x. Let's combine our x's, add 2x, add 2x. 8 equals 8. Oh, true statement. So that would be all real numbers is our solution, which is an identity. All right, let's solve this one. Remember, we need to get a common denominator. Always put your ones in if there is not a denominator there. So we're going to times by 2, times by 2, times by 4, times by 4. So now our denominators are all 4, 4, and 4. We're solving, so we can't ignore it. 2y plus 3 minus 2y equals 20. So then we have a 0. 2y minus 2y is 0 plus 3 equals 20. 3 equals 20. Uh-oh, no solution. That's not a true statement, and that is because there's a contradiction. Very good. We saw all 3 types of solutions we could see. All right, number 15 says state the domain. Remember, the denominator cannot be 0. So our true statement is 2x plus 3 cannot be 0. Solve for x. 2x cannot be negative 3. X cannot be negative 3/2. So make sure you say all real numbers, just x cannot be negative 3/2. This one, same thing. Don't be that person that says the top can't be 0. The top can be 0. It's the bottom. So our true statement is 6x minus 1 plus 3 cannot be 0. Subtract 3. So we have 6x minus 1 equals negative 3. Divide by 6. Or I could distribute 6, whatever you feel comfortable with. So now we have x minus 1 equals negative 1/2. Then we're going to add 1. x is equal to, guys, we have to be able to add fractions by hand because our calculators won't do it for us, and decimals really aren't acceptable. So what I would do is negative half plus 1, and I would go 1 is the same thing as 1 over 1. To add these together, I need a common denominator, so I'm going to times by 2, times by 2. So I'm looking at this right now. Negative 1/2 plus 2 halves. Now you can't, in your final answer, ignore the denominator, guys, because we're now at our final answer. We've got to keep that denominator there. So we got a common denominator so that we can add our numerator. So we have x is equal to negative 1 plus 2 is 1. So we have 1/2. Remember, you don't add the denominators. You just combine like things in the numerator. So in your final answer, guys, do not ignore the denominator. Do not get that confused. Okay, let's look at 19. The sum of 3 times a number and 7 is 22. So I start with equals 22. There's my is 22 part. The sum, we have an addition of 3 times a number and 7. So the question is this 3y plus 7 equals 22, or is this 3 times y plus 7 equals 22? We've got to read this very carefully and decide. The sum of 3 times a number and 7. I'm trying to decide here. The sum of 3 times a number and 7. This one should really just be this one right here, this true statement. So we have 3 times a number and 7. The sum of 3 times a number and 7. Now, if you'll notice in the instructions, it does say just to write a truth statement, and then you don't have to solve, and hopefully at this point you'd be able to solve. So, all right, 20% of a number equals the difference of the number and 12. Okay, so our number we don't know is x. It's the same number here, so it's x. So 20% of a number, remember how to do that. You'll do the number times 0.20. And just a reminder, that's a times sign. And then that's equal to the difference of the number and 12. So there we go. There's our true statement. It does say we don't even have to solve. But if we did, don't let the decimal throw you off. Remember, this is the same thing as 0.20x equals 1x minus 12. So then we would just subtract 1x, subtract 1x. That'd be negative 0.80x equals negative 12. Divide by negative 0.80. So you guys get the picture, right? It's not a big deal if we have decimals here. We'll just still combine like terms. All right, it did tell us we didn't need to solve though, so we would have stopped right here. Okay, Sean is 8 years older than Peyton, and the sum of their ages is 18. What are their ages? So first of all, let's start with Sean. He is 8 years older than Peyton. Well, actually, let's start with Peyton. We have no idea what Peyton's age is. Let's call their Peyton's age X. Sean is 8 years older, so that would be Peyton's age plus 8 additional years. It says the sum of their ages is 18. So out of their ages, x plus 8. There's the sum of their ages, and that's equal to 18. And now we'll go ahead and solve to find their ages. So combine like terms, x plus x is 2x plus 8 equals 18. So subtract 8, 2x equals 10, x equals 5. So make sure you go back and answer it completely. Peyton is 5 years old, and 5 plus 8 is 13. So Sean is 13. All right, so we have our 2 answers. Pretty straightforward, you guys. All right, Logan is in elementary stats class and has test scores 85, 81, 84, and 77. If the final exam score counts as 2 test scores that we don't know, what score does he need to get to be able to have an average of 80? So remember, to do average, we'll add up all our scores. Our first 2 X's we have, technically it's just 1 test, but they're worth 2 exam scores. So 2 X's there, plus 85, plus 81, plus 84, plus 77, divided by the total number. That's how we do averages. 1, 2, 3, 4, 5, 6 test scores. We wanted to, in the end, equal 80. So now from here, let's go ahead and do this. So we have 2x. We're going to combine like terms. On top, 2x. I'm going to hurry and add 85 plus 81 equals 84 plus 77. So we have plus 327 over 6 equals 80. Now solve. Get a common denominator, or same thing as timesing 6 over to this side. So we now have 2x plus 327 equals 480. Solve for x. 480 minus 327. 2x equals 153. Divide by 2. So x is equal to 76.5. They have to get a 76.5 score on the final exam to end up with that average grade of 80. That's all I'm going to do for the first part of the video. I will record and upload another video shortly for the rest of the problems.